Alrighty, folks. Gonna recreate the short lecture on simple machines and mechanical advantage, and we're gonna use as our example the inclined plane or ramp, which is one of the most fundamental simple machines. And so you've seen these ramps, and they're used to allow handicapped people to go up into buildings, people who are in wheelchairs or in mobility scooters. And so here's a representation of a ramp. Now this ramp lifts up 1 meter here, but this ramp is 4 meters long along the long axis here, the hypotenuse of the triangle. And let's draw a little sketch of a kid in a wheelchair here. We'll call him Timmy. And Timmy is a 500 Newton person. That's his weight. And he's going to be working himself up the ramp. Now, if you were to climb straight up the 1 meter, using stairs or something else where the force is directed straight up and down, you would do a certain amount of work. And let's just say that you were the same weight as Timmy. So the work done would be your weight times the distance you traveled upwards. And your weight is 500 newtons. And you're going to go up 1 meter. So you would do 500 joules of work. Now, over here, Timmy's not going to do 500 joules of work. Timmy doesn't have to lift his entire weight because Timmy is on an inclined plane. And we know that there's a fraction of his weight that's pulling him down the plane. That's the only force he has to overcome. So that force parallel is equal to his weight times the sine of the angle. Now, I haven't given you the angle, I haven't given you the theta, and so you can't just take the sine of theta, but sine of theta is also equal to the opposite side divided by the hypotenuse. So this would be 500 times 1 over 4. And so that means that the part of Timmy's weight that's down the ramp, the part he has to overcome when going up the ramp, is 125 newtons. So the work done by Timmy is going to be this parallel force times the distance he has to go, which is 125, but he has to go 4 meters. And in the end, he also does 500 joules of work. So what is the point of this simple machine? The point is that Timmy gets to use a reduced force but a larger distance to do the same work. So a simple machine is one that allows you to trade increased distance for reduced force. And that's useful because sometimes you're just not that strong. When it comes to Timmy, Timmy's in a wheelchair and he's using his upper body to enter whatever building, library, or school that he's going to. Whereas you get to use your lower body, your legs, which are much stronger. So asking you to climb up stairs, and I agree that stairs are themselves sloped a little bit, but let's just pretend it's a ladder. You climb a ladder to get into the library or the school. Then you're using your legs, and Timmy has to use his arms, and they're not as strong. So we've got a way for him to use a reduced force. Now, what's really interesting about all of this is this thing right here, this 1/4 came from the sine of theta. And this thing right here it tells us by how much do we get to reduce the force. So mechanical advantage which is abbreviated MA to most of us, is the ratio of the distance along the ramp to the distance up that you're going to be traveling. And so in this case, the distance along the ramp is 4, the distance up is 1, and so this is a mechanical advantage of 4. Now notice this is 4 meters and 1 meter, and then the answer here is just 4 with no units whatsoever. It's meters divided by meters or nothing. It's a ratio. In fact, older people would say this is a 4-to-1 machine. And but the modern usage, you just say mechanical advantage of 4. So what you do is you take your weight and you divide by the mechanical advantage to find out what your force is. And that's how you handle simple machines.